This video is on interactions between air masses. In our previous video, we looked at how to classify air masses based on either temperature or the amount of water vapor. So now we're going to look at what happens when two or more air masses collide or run into each other. So our objectives: I can describe what happens when two air masses collide. I can identify the different fronts from an illustration, and we'll talk about what a front is. So, when air masses move into an area and interact with other ones, that causes the weather to change. A lot of our weather is caused by the interaction of two or more air masses. In the United States, our air masses are moved by what are known as the prevailing westerlies and jet streams. And when we talk about air movement, we're going to talk about the different types of wind, including the westerlies and jet streams. So a front is the boundary where unlike air masses meet but do not mix. So that's going to be our key vocabulary word for this video, is the front between two air masses. So a cold front happens when we have a cold air mass that runs into a slow-moving warm air mass. Cold air is more dense because those air molecules are closer together, they're colder, and so they're more dense and they're going to sink down. Warm air is much more spread out, those molecules have a lot more energy, and so they're lighter and it rises. So the warm air is quickly pushed up above the cold air. That's the front, where that cold air meets the warm air. And if the cold air runs into a warm air, then that's a cold front. So because that warm air quickly rises, it expands and cools, because we know as we get higher up it cools down, and forms lots of cumulonimbus clouds, a lot of thunderstorms, because it's happening so quickly. And you're going to get a lot of heavy rain, thunderstorms in a small area. Cold fronts usually move pretty quickly, and so these are pretty abrupt changes. And after a cold front passes, you're kind of in this colder air mass now, you're going to get drier air. Cold air holds less moisture than warm air. It's kind of a key fact you might want to think about and jot down. So you're going to get this colder, drier air behind the front, and you're going to have clear skies, lower temperatures, things like that. So here's an illustration of this cold front. We've got the mass of cold air moving in, and then it's running into this warm air, and this warm air rises up. And remember, when air rises up, it's going to cool down and form lots of clouds. And because it's happening so quickly, you're going to get thunderstorms. This line with the blue triangles, that represents a cold front on a weather map. So you're going to want to include that in your notes, because you're going to want to know those symbols and what identifies different fronts. All right, next we have a warm front. Warm front is when warm air moves onto a cold air mass. Before we had cold air moving onto a warm air, now we've got warm air onto a cold air. Again, remember, cold air is denser, so the warm air moves over the cold air. You're usually going to start off by seeing cirrus clouds. Remember, in our cloud video we talked about how cirrus clouds usually indicate storms or rain. After these cirrus clouds form, they get heavier and lower, and they form more stratus clouds. When you're getting a warm front, usually you're going to get some moderate rain over a large area. When those warm fronts are moving a little bit slower, the weather may be rainy or cloudy for several days, so it might be a little bit more extended period. But afterwards, you're going to get pretty warm and humid weather. Remember, I said warm air can hold more moisture than a cold air mass. So again, here's our picture. We've got this warm air moving in and moving up and over the cold air because the warm air rises. And again, you're getting warm air rising, so it's going to rise and cool, so you're still going to get that cloud development. The symbol for a warm front is a red line with half circles, kind of look like half moons. So that's the symbol for a warm front. Next, we have a stationary front, and stationary means it doesn't move. So cold and warm air masses meet, but neither one can really move, so they kind of have a standoff. You're going to get some water vapor at the border. You get some warm air that condenses. You get some rain, snow, just some drizzly weather. If it remains stalled, which means it doesn't really go anywhere, then you're going to get probably a lot of days of those clouds and precipitation. And here's our picture representing two air masses that are meeting but not really able to move each other. On a weather map, it's an alternating line of cold and warm. Notice if the cold air is moving on this picture from, to the right, the blue triangles are pointing to the right. If it's moving to the left, if the warm air is moving to the left, these red half circles are pointing to the left. So the direction the symbols point is important. Finally, the last front we're going to talk about is called an occluded front. And this is when you have warm air that's caught between two cooler air masses. So the dense cool air mass moves in, and that it's running into a cold air mass, and that warm air mass gets pushed up and rises in the middle. The temperature around the ground becomes cooler because it is a cold air mass at the bottom, and the warm air mass is cut off or occluded. That's where the word comes from. So it's cut off from the ground. And this means you'll usually get some heavy cloud cover because you're still getting that rising warm air. And whenever you have rising air, it's cooling down, so it's condensing and forming clouds. So this is our picture for the occluded front. You have your advancing cold air, your receding, which means moving away, but that cold air overtakes the receding cold air. So you've got your two cold air masses here, and that warm air is moving up in the middle. So at the boundary where they meet is our occluded front. And notice we have the symbols on the same side because the cold air that's overtaking the other cold air mass is moving in that direction. So again, they still point in that direction. So those are the 4 different types of fronts. You'll notice a lot of times all of them are causing some kind of weather because some kind of rising air is involved, which is going to form clouds. So usually when we have fronts coming through, that's when we're experiencing a change in weather.